Welcome dear viewers in this video lecture. Today we will discuss how any number n with base b can be converted into decimal number. For that, let us recall what we discussed in previous lecture was that any number in base b will have integer part and fractional part, and it can be designated in this form where d is the symbol and subscript is the weight of each symbol. Now this number n can be represented by the number in decimal system by the following expression: d n minus 1 multiplied by r n minus 1 plus d n minus 2 multiplied by r n minus 2 plus so on up to d 2 multiplied by r raised power 2 plus d1 multiplied by r raised power 1 plus d0 multiplied by r raised power 0 plus d minus 1 multiplied by r raised power minus 1 plus d minus 2 raised to power r minus 2 plus so on plus d subscript minus m multiplied by r raised power minus m. This is the expression we will be using to convert any number with base b or radix r. This is the radix we will be using to the number that is our decimal number. So we need to keep the track of this formula. Let me now take certain examples to see how this expression works. The first example is as follows, and here we have to find the value of the y. The given number is in base 2. Recall that this part is the fractional part, integer part, and this is the fractional part. Let me rewrite this number for you in a simplified manner. Now this is the radix point, and this symbol is at position 0. This symbol is at position 1, 2, 3, 4, and this symbol is at minus 1 and minus 2. What we require to do is we need to multiply each symbol by their respective weight, and the respective weight here is r raised power minus 2, and recall the given r is 2, so it is 2 raised power minus 2, 2 raised power minus 1, 2 raised power 0, 2 raised power 1, 2 raised power 2, 2 raised power 3, and 2 raised power 4. We need to evaluate these expression now and do the calculation. This can be simplified as 16 plus 0 plus 4 plus 0 plus 1 plus 1 by 2 plus 1 by 4, and this can be simply written as 21.75 in the base 10. So this number in base 2 can be written in base 10 as 21.75. Now we have another example, 57.4 in the base 16. We can write here h also, because h stands for hexadecimal and h is, we have the base as 16 into the decimal numbers, and we have to again find here the value of the y. Again rewriting this number in integer part and fractional part along with their weight. So this is the point, and it is a 0 weight, it has the weight of 1, and this has the weight of minus 1. Therefore, multiplying each symbol by the respective weight, that is 16 raised power 1 here, 16 raised power 0, and 16 raised power minus 1. Now, what we require to do, we need to evaluate this expression and find the decimal number. Therefore, this can be simplified as 80 plus 7 plus 4 divided by 16, which can be written as 87 plus 1 divided by 4, which is equal to 87.25 with the base 10. Using similar procedure, you can do these two problems at your own, and I will write the answers here. The answer for this question will be that y will be equal to 23 base 10, and y here will be equal to 2989 base 10. Therefore, the bottom line is that to convert any number in certain base b to the decimal base, what we do is we simply multiply each digit with positional weight first, and then we simply add the result. Let us now increase the level of the problem on same concept. The first problem is 73 with base x is equal to 54 with base y. So that the two numbers are equal, and what we require to do is we need to find x and y. So the concept here is that we convert this number into decimal number first, and similarly we convert this number again to the decimal number, and we equate these two numbers, and this will be very easy for us. Therefore, we write this expression simply as 7x plus 3 is equal to 5y plus 4 implies 7x minus 5y is equal to 1. Now, this is the final equation we will be getting out of the problem. Now, we need to find the values of x and y so that LHS is equal to RHS of this equation. So we do not have only one value of x and y for which this equation is holding true. Therefore, x and y will have infinite number of values. In fact, this is a line mathematically speaking. So, but the base will be always an integer. So, not every point on that line is solution to this problem because base is an integer. So here the possible values of x and y will be 3, 4, 8, 11, 13, 14, and so on. The second problem is that we have an equation where we have different numbers and all the numbers are on same base, that is x, and what we require to do is find x here. Again, the procedure will remain same, that is we convert this into base 10, this also to base 10, and this also to the base 10, and analyze the equation. So analyzing or calculating this equation, we will see that x square plus 3x plus 5 plus x square plus 4x plus 4 is equal to 3x square plus 2x plus 3. Solving this equation will result us x square minus 5x minus 6 is equal to 0, which when factorizing will give us x minus 6 plus multiplied by x plus 1 is equal to 0. It implies x is equal to 6 or minus 1. But the thing is that base x is a base and base can never be negative, so x is equal to 6 is the required answer. The final problem for today's session will be under root of 41 with base b is equal to 5 with base 10. So we have to find the value of b for which this equation is true. Again, we have an under root first here, so we need to cancel out this under root. Therefore, we need to square on both sides. So it will be under root of 41 b whole square is equal to 5 with the base 10 square. This will be equal to 41 base b is equal to 25, which will provide us 4b plus 1 is equal to 25, and implies 4b is equal to 24 implies b is equal to 6. So 6 is the answer. That is all for now. Thank you.